A community swim team has 150 total swimmers. That swim team is divided into advanced, intermediate, and novice swimmers, where we have 75 advanced swimmers, 47 intermediate swimmers, and we're told the rest have to be novice swimmers, but we don't know how many. What we can do is think of all the swimmers minus the advanced minus the intermediate. So we'll do 150 minus the 75 advanced swimmers minus the 47 intermediate swimmers to see that there are 28 novice swimmers. So we have all 150 swimmers separated into their different categories: advanced, intermediate, and novice. We also know that some of these swimmers practice 4 times a week. Some of the advanced, some of the intermediate, some of the novice swimmers. We can create one circle to represent all of the swimmers who swim 4 times a week, and we know that it's going to need to overlap each of the other circles that we have in our Venn diagram. So we'll place it maybe right in the center so that it overlaps a little bit with the advanced, a little bit with the intermediate, a little bit with the novice swimmers. We're going to use this diagram to separate the advanced swimmers who practice 4 times a week from the advanced swimmers who don't practice 4 times a week. We know that 40 of the advanced swimmers practice 4 times a week, so we're going to take 40 of the 75 advanced swimmers and move it into our 4 times a week circle. That would leave us with only 35 advanced swimmers in the community swim team that don't practice 4 times a week. So just to clarify here, the 35 and the 40, they're both the group together to make the advanced swimmers, but only some of them are practicing 4 times a week, and some of them aren't. So we're separating the 75 swimmers accordingly. We'll do the same thing for the intermediate swimmers. 30 of the intermediate swimmers practice 4 times a week, which leaves 17 of the intermediate swimmers who do not practice 4 times a week. And the novice swimmers, 10 of them practice 4 times a week, which leaves 18 who do not practice 4 times a week. Before we say that our diagram is complete, it's worth checking that we've accounted for all 150 swimmers within the 4 circles that we've drawn here. So if I add up my 35, 40, 30, 17, 10, and 18, I'll get 150, which means every single swimmer has been placed in the correct position in the diagram. We can use this diagram as a reference point when we're asking probability questions about this group of swimmers. Suppose one member of the swim team is randomly chosen. What's the probability that the member is a novice swimmer? To answer that probability question, we just need to know how many novice swimmers are there and how many total swimmers are there for the swim team. We know both of those numbers, in fact. Looking in our novice swimmer circle in our Venn diagram, I can see all 28 of the novice swimmers, and those 28 do belong to the swim team. So we have 28 over the total number of swimmers, 150. Suppose one member of the swim team is randomly chosen. What's the probability that the member practices 4 times a week? To find this one, I just need to look at all of the different swimmers that exist inside the 4 times a week circle. I have 3 groups here. I have the advanced swimmers, the novice swimmers, the intermediate, and the novice swimmers. All of these different groups have some of their swimmers that practice 4 times a week. So we're going to need to add together the 40 advanced swimmers, the 30 intermediate swimmers, and the 10 novice swimmers to make our numerator, which represents all of the swimmers who practice 4 times a week. Suppose one member of the swim team is chosen randomly. What's the probability that the member is an advanced swimmer and practices 4 times a week? Well, we actually have our advanced swimmers separated so that we can see 40 of them practice 4 times a week. So all we need to do is write the ratio 40 for the number of swimmers who are both advanced and practice 4 times a week out of 150, the total swimmers on the swim team. Again, suppose one member of the swim team is chosen randomly. What's the probability that the member is an advanced swimmer and an intermediate swimmer? Well, this isn't explicitly stated in the problem, but the different levels of swimming are completely separate from each other. You're either novice, or you get a little better, you become intermediate, or you get a little better and you become advanced. But you wouldn't be in two categories at once. You're either advanced or you're intermediate. In this case, those two groups don't have any overlap, so there's a 0 chance of picking somebody who qualifies as both intermediate and advanced. Are being a novice swimmer and practicing 4 times a week independent events? Well, if they are, then the probability of being a novice swimmer and practicing 4 times a week would be exactly equal to the probability of being a novice swimmer multiplied to the probability of practicing 4 times a week. Now we can find each of these probabilities and just check, do the results match? There are 10 swimmers who are both novice and practice 4 times a week, so that probability would be 10 out of 150. Probability of being a novice swimmer would be 28 over 150. And the probability of practicing 4 times a week, that's 80 over 150. And if we multiply these two fractions, 28 over 150, 80 over 150, we get 0.0996 approximately. And if we compare that to the probability of the intersection, and so novice swimmers and practicing 4 times a week, 10 divided by 150 comes out to 0.0667 approximately. And these values don't match. Since they do not match, we know that we are not looking at independent events.